Hi guys, welcome to today's video. So today we'll be seeing something on C++20. So one of the features that C++20 provides is to define something called as concept and requires. So today we'll be seeing what a concept is and how you can make use of concept in your code. So concept, you can just think it as a type, defining a new type itself where you can define some constraints on that particular type. Sounds good, right? So, as an example, we will start with this particular example, and we will further see more examples on this concept. So, here what we are doing is we are defining a template method called add, which we are trying to add to arguments that we are getting here. For earlier, if we are not using concept, what we will try to do is if it is a template method, we will define like template type name t over about this particular method. So instead of that, instead of defining a type name, we will define a custom type called a concept. We will define a concept called numeric, which will adhere to this particular constraint, whatever we are setting it to. So here we are setting a constraint like that particular type should be an arithmetic type. This particular type should be an arithmetic type. That is what the concept is defined here, and we will make use of that concept as a type in this template method. So what happens here is when we define like that, this particular method will give you the correct output. But when you try to pass some other argument which is not the numeric type or the arithmetic type, during the IntelliSense, Visual Studio IntelliSense itself will give you an exception that or the error that this particular argument list doesn't match the argument type that we are expecting. So this is pretty useful because this here we are getting the error during the coding phase itself. So otherwise, if we had defined a normal template method, we would have got this error during the compilation phase, and the error message will not be explicit. And the error message that we will be getting will not be explicit, and we will find it difficult to know from where the error is coming. You might be familiar with the template errors which we are getting. It is not straightforward to understand the template errors and resolve them. So this is one of the examples we can start with, and now we can go to further examples to see what the other uh, use cases are. So here we are again defining a particular template method, which is here we have defined a concept called incrementable, and we have set a constraint on this concept called the type T should support this particular pre-increment operator. So this is how you define a concept. Therefore, this requires adds additional supports this concept by providing more properties, by providing more constraints. It you can think of it as it is a lambda function which you can define for a concept wherein you can give multiple constraints for that particular concept. So requires takes in a template type which we are defined here, and it can place a constraint like it should support this pre-increment operator. This is how you will define it like this, and then you will define your template method, and you can use your template method here. So if you pass any other type which doesn't support this pre-increment operator, it will throw error then and there. The IntelliSense will throw error then and there. So that is the one of the advantage that we are getting out of using this concept and request. Also, your code will be much more readable and much more explicit. You don't need to do a documentation of your code. If you define your template type like this, if you define concept for each of the template type that you are using, then it will be much more explicit and it will be much more easier for the user or the programmer or developer who is coming, who is trying to work on your code. It will be easier for him to understand what this particular type is about. So what you are defining, what you are intending with this particular template method, it is will be very explicit. And also you can reuse this particular concept everywhere in your code, and this is a one-time definition that you can do in your header file or some common place where you can reuse it in an entire code base. So if you want to change any constraint, you can just go to that particular place where you have defined the concept, and you can change the constraint here and it will affect the entire code base. So that is another advantage that you will get out of this defining a concept. So we'll see some other example. So this is a particular interesting example where it is a common use case where we try to iterate over a container. So you can define this method, like what this method essentially does is it tries to iterate over each element in the container and try to print its value or perform any other operation, you can just assume. So if that is the case, sometimes in the in this kind of an API, we tend to use different kinds of for loop. So we might use a range-based for loop like I've used here, or you can use this that loop variable type for loop where you will define a loop variable, etc. So different ways you can define. For this particular use of this range-based for loop will not be supported by every container out there because some of the containers won't support the iteration functionality. It will not it will not be iterable. The container will not be iterable container. So in that case, this range-based for loop will throw an error. So if you know that you are using a range-based for loop, it is your responsibility to define the template type. You define a concept for the template type container, like that particular type should support iterable. It should be an iterable container. How you will define that particular constraint is you define a request of that template type T such that that type T should have a member function begin and the type T should have a member function called end. So if you define like this, and this is of type input iterator, if you define like this, then it means that that particular container, if that particular type has begin and end API, then that means that particular container is an iterable container, and this for each loop or the for range-based for loop will work without any issues. So here we are trying to what we are trying to do is we are trying to define a vector and a list, and we are passing these two to these two APIs. So this will work without any issues because this particular these two containers support this iterator. So that is what I want to cover in this particular video. So I have written a blog post on this also, like the concept and requires. You can check that out in that blog link, the description box below, and you can go through this blog post. And there are some related blog posts associated with templates that will be much more helpful to you. So I have explained in detail what the university concept is about and what is the advantage of concept and why we are going for a concept, and we use the same examples that we discussed here. So you can go through these things, and if you have some doubts, you can just mention in the comment box below, and do mention in the comment box below whether you were aware of this particular feature before. If it is new to you, kindly support this channel and see you in the next video.